In our previous session, we had discussed about wings and high-lift devices. Let us start off with aircraft performance in this chapter. Under airplane performance, we will be studying about introduction, equation of motion, static and dynamic performance, thrust required, thrust available, power required, power available, rate of climb, range and endurance, takeoff performance, landing performance, turning flight, accelerated rate of climb, and finally Venn diagram. Let us start off with the introduction. Airplane performance deals with the whole airplane, not just an airfoil or wing. Airplane is considered as a rigid body on which is exerted four natural forces, that is thrust, propulsive thrust, drag, lift, and weight. Concern is focused on the moment of the aeroplane as it responds to these forces. Such consideration forms the core of flight dynamics, an important discipline of aerospace engineering. Studies of airplane performance and stability and control both fall under the heading of flight dynamics. In this session, we will no longer be concerned with aerodynamic details. We will generally assume that the aerodynamists have done their work and provide us with the aerodynamic data for the given aeroplane. These are usually packed in the form of drag polar for the complete aeroplane. CD is equals to CD naught plus CL square by pi EAR. CD is the drag coefficient of the complete airplane. CD naught is the parasitic drag coefficient at zero lift. CL square by pi EAR is the induced drag. The graph here is called the drag polar graph with the approximations made with the formula CD is equals to CD naught plus CL square by pi EAR. Figure A, CD is plotted versus CL and figure B, CL is plotted versus CD. The two representations are identical, is basically a simple mirror image of each other rotated on the side. In these images, we can notice that the negative values of CL pertain to negative lift, which occurs when the angle of attack of the aeroplane is less than 0. This situation is not encountered frequently in the analysis of aeroplane performance. Hence, only that portion of the drag polar associated with positive CL is usually shown. The roadmap for this session. A study of aeroplane performance is frequently based on Newton's second law, which dedicates the motion of aeroplane through the atmosphere. We first obtain the equation of motion. The remaining two forms of the equation are 1. The form associated with the assumption of unaccelerated flight leading to the study of static performance, and the other, the form associated with acceleration of aeroplane leading to the study of dynamic performance. Under dynamic performance, we will be studying about the takeoff and landing characteristics, turning flight, Venn diagram, and then accelerated rate of climb. Under static performance, we will be studying about power required, power available, thrust required, thrust available, rate of climb, time to climb, and finally range and endurance. Let us start off with the equation of motion and static and dynamic performance in the next session. Thank you.